Okay, so now we're on the Factorialize a number. This is a free code camp basic algorithm scripting problem. And the instructions are to return the factorial of the provided integer. Down here it gives us a little information, but what we need to know right here is the factorial of 5 would be 1 times 2 times 3 times 4 times 5. So of course we're going to need that to scale up to as big a number as they can throw at us. Let's see if they, yeah, down here shows they're going to give us a function that calls it 20 times, and it's going to be a really big number. So we'll keep that in mind, but it's not really information we need to know right now. There are 3 ways to get this done, at least 3 ways, but you can use a for loop, a while loop, or you can use a recursive function. And I'll show you all 3 of those ways. But I think the easiest for most people who are just starting out would be the for loop. So we'll get started with that one first. So what I'm going to do first is I'm going to set a temporary variable. I'm going to call it answer, but it could be called whatever you want. And I'm going to set it to 1. Now one thing to remember when we're doing this is that multiplying anything by 1 is kind of pointless, and multiplying anything by 0 will always get you 0. So we're going to kind of skip those numbers, and I'll show you what I mean on this next line. So when I'm writing out my for loop, I'm going to say var I equals 2. I could make this 1, but like I said before, multiplying anything by 1 is pointless, and it's just kind of a wasted iteration through the loop. So I set that to 2, and I'm going to say if I is greater than or equal to num, we're going to stop. So basically when it hits the same value as num, it's going to stop, and then we'll say I plus plus. And all I'm going to do in here is I'm going to say answer equals answer times I. So basically the first time it runs through the loop, it's going to say 1 times 2. And then the next time it runs through the loop, the answer is going to be 2. So it's going to be 2 times 3, because I is going to be 3 the next time it runs through the loop. And it goes on until I equals the number. And if we return our answer at the end, this should be right. And it's not. Oh, it's because the loop wasn't actually run. We keep running the loop while I is less than or equal to num. That was a big mistake, but kind of understandable, I hope. And that was the answer. There's a lot of modifications we could do to this, but for now, just going to show you this easy one that you probably already have seen before. Answer times equals I. Instead of saying answer equals answer times I, this is the exact same thing. Alright, so that was the for loop. And if we were going to do this in ES6, it wouldn't be much different. It would just be let answer and for let I. And I don't have the code in front of me. It's something like JS hint ES version 6. Yeah, that is how you do it in ES6, and that's the exact same function. So we'll get rid of this for now, and we'll do a while loop. Now in while loops, at least for me, you run into a lot more infinite loops, so make sure that you watch what you're doing. So I'm going to do the same thing. I'm going to say temporary variable. I'm going to let answer equals 1, and I'm going to say while num is greater than 1, because remember, we could say greater than 0, but timesing it by 1 is pointless. So while the provided argument num is greater than 1, answer equals answer times num. And in this loop, I'm actually going to change num every time through the loop. So I'm going to say minus minus num, so I do not run into that infinite loop. And this should be all I need. If I return answer at the end, and it is basically the same logic. It's just starting at, we'll just call it 5 because that's what it says first. Starting at 5, and it's decrementing itself each time through the loop until it gets to 1. Okay, so now I'm going to show you the recursive function way to do this. It is probably harder to understand if you're just starting out. So if you don't get it, don't worry about it, but I'm just going to show it to you just so you can see it. Remove all of this, and inside of our Factorialize function, we'll make a new function. I'm going to write this out the long way to hopefully show you more of what's going on. We'll say function recurse takes a number, and I'll just call it I. If I is less than or equal to 1, we'll return 1. And if it's not less than or equal to 1, we'll return I times recurse I minus 1. So what's happening here is, we'll say the first time we call it Factorialize with 5, it's going to go through here, recurse 5, and of course 5 is not less than or equal to 1, so it's going to return I times recurse times 4, or recurse with the argument of 4. And it's going to keep doing that. It's going to call I times recurse with the argument of 3, all the way up till it gets to a 1, and then this function is just going to return a 1. And once that is done, then all the other functions will finally have their answer, and it'll just build itself up. I'm probably not explaining this the greatest, but if I can write this out, well, for now let's just try it. Let's make sure it's going to work. We'll call the function return recurse num. We'll give that a shot. And that worked. So if I can write this out, make it a little easier, we have what's called a call stack. I guess I'll start it down here. We'll call recurse 5 is waiting and it's waiting for recursive 3. So once recursive with 1 is called, it's going to return a 1. And this is returning 2 times 1. And this 3 times 1 times 2 is 2. And this one returns 4 times 3 times 2. And this one 5 times 4 times 3 times 2. So I don't know if that gives you a better explanation or not, but this is what's happening. Is there's a thing called a call stack. Recursive 5 calls another function, and that makes a new entry into the stack, and the entries go up and up and up until this one does not call a new function, so it starts to go back down the call stack, and it's just building it up until it gets its answer down at the bottom, and it finally returns for the last time. So I hope that answered some of your questions. But now I'm ready to show you how this can be done with less code. So there's something called an immediately invoked function. It's called an IFI. And the way you write an IFI is you put a parenthesis before the function keyword, and then you put a closing parenthesis around the whole function, and you just call it right away, immediately. Alright, and this is the same thing. What happened here? Oh, I'm not returning. I need to return. It's an IFI. Okay, and that worked. If we want to make this a lot cleaner, it might not be cleaner, but to make it a lot less characters, first thing we can do is this. You can make your if statement all onto one line. And this, depending on who you ask, can be bad practice to do that, but this is still the same function. And we can also do something like this. This is using a ternary. I less than or equal to 1 question mark. And that's the same as saying if I is less than or equal to 1, or return 1, or return recurse. So that will do the same exact thing. That's just another way of writing an if statement. It's called a ternary operator. And we can also do this. We say const recurse equals I as an argument, and an arrow function that will let us get rid of the return. And what am I missing here? So we can write it out like this. This is not too readable, but that is another way to write it out. If you like playing code golf, which means, write it in the least amount of characters possible. And of course, if we were doing that, it would be something stupid like this. Just call the function R. And this would be N. And I think that would be the code golf way to do it. Still the same function, just almost completely unreadable. Well, I think I went far enough with that one. Hopefully you understand how the recursive function works after this. And if you have any questions or comments, leave them down below. Thanks.